Hi, year 9. We're going to continue with 7b, which is index laws for multiplying and dividing. So for example, if you were given 5 raised to the 18th power multiplied by 5 raised to the 10th power. This is a multiplication question, and our step is to expand using multiplication, or we can do a quicker way and just add our indices. So let's see what would happen. If I expanded 5 to the 18th power, I'd have to write 5 times 5 times 5 times 5, and I'd have to do this 18 times. And then I'd have to multiply it by another 5 10 times. So really, by the time I'm done, I'm going to have a ton of 5s, and I'm going to have, let's see, 18 5s times another 10 5s. So I'm really going to have 28 5s. So to make this a little bit faster, why don't I just write 5 to the 28th power? So if I add my indices, that's really what happens. 18 plus 10 gives me 28. And that will save me the step of having to expand. So this, adding the indices, is going to be a lot quicker when I have to multiply. But I do have to notice that my bases have to be the same. I couldn't do this if I didn't have the 5s matching as my bases. So again, if the 5s are matching as my bases and I'm asked to divide, I can again expand and divide out my common factors, or I could just subtract the indices. So let's see how this works. If I were going to write out 18 5s, so 5 times 5 times 5 times 5 times 5 times 5, and I do this 18 times. And then I wind up dividing by 5 times 5 times 5 times 5 times 5, 10 times. What I'm going to wind up getting in the end is I'm going to reduce by common factors. So 5 divided by 5 cancels out because 5 divided by 5 is 1. I can cancel these 5s out and these 5s out, and I could keep going. But because I have 18 5s in the numerator and 10 5s in the denominator, I'm going to have 8 of them left in the numerator. So I'll wind up canceling all my 5s out of the denominator, and I'll wind up with 8 5s left in the numerator. So a faster way to do this, instead of having to expand and reducing by common factors, I can just notice that 18 and 10 are going to leave me with 8. So another way to do that is by subtracting the indices. 18 minus 10 leaves me with 8. So let's put these two rules to our test here. 3 to the 6th power multiplied by 3 to the 4th power. We said that our rule was when we multiply, we add our indices. So 3 is going to be raised to the 6th plus 4. So I'm going to get 3 to the 10th. When I have 4 to the 5th times 4, and there's no number here, there's always a 1. So I have 4. 5 plus 1 gives me 6 4s. 4 times 4 times 4 times 4 times 4 times 4. Now when I have 7 to the 9th divided by 7 to the 5th, we have a division question. And our rule was when we divide, we're going to subtract our indices. That's the quicker way to do it. So I'm going to be left with 7, but 9 minus 5 is our new index of 4. And last but not least, 6 to the 8th divided by 6, which is to the 1st power, will leave me with the same base, 6, 6, and 6. 8 minus 1 is 7. So that was example number 1. Let's look at example number 2. Simplify each of the following using your index law for multiplication. So again, for multiplication, we add our indices. So I'm going to wind up saying that x is going to be raised to the 4 plus 5 plus 2. Another way to say that is just x to the 11th. For part B, I'm going to end up with x to the third, and then I have another x squared. So those are my x's. So 3 plus 2 are the two indices for my x. For the y, I have a 4, and then I have nothing. So remember, there's always a 1 there. And I wind up with x to the 5th and y to the 5th. So following the same idea, for division, I have x to the 10th divided by x squared. And our rule for division was to subtract our indices. So let's go ahead and subtract our indices. X to the 10 minus 2, which is the same thing as x to the 8th. So last but not least, our last example is going to be what we do when we have coefficients mixed with pronumerals, and I have to follow these same rules. Remember, our rules are only for the indices. So 3 times 2 is still 3 times 2, and I get 6. But my m has 2 different indices, and when I multiply, I add my indices. So 4 plus 5. So my answer will be 6m to the 9th. Again, 12 and 4 are my coefficients. So 12 divided by 4 is still going to give me 3. But for my y's, they have indices. And my rule today for indices is that if I divide bases with indices, I'm going to subtract my indices. So 7 divided by, y to the 7th divided by y to the 3rd will give me y to the 7 minus 3. So again, my coefficient of 3 just follows my normal rules for division, and then y is now to the 4th power. Let's see what this looks like in a vertical setup. So if you set up your question vertically, I have 8 divided by 12. Well, 8 divided by 12 is going to be what I would do with 8 divided by 12, whether it has pronumerals next to it or not. 8 divided by 12 is going to reduce down. If I divide by, let's see, 4, I'll get 2 and I'll get 3. So 8/12 reduces to 2/3. Then we have a to the 6th, so we'll use red for that. A to the 6th divided by a to the 2nd. Since I'm dividing bases with indices, I'm going to subtract my indices. So 6 minus 2 is 4. So I'll end up with a to the 4th. Let me make that a little bit shorter. And then last but not least, I have my b's. We'll do those in green. And the b's, again, are dividing. So 3 minus 2 gives me 1. When I divide the base, I subtract my indices. And that takes me back to the first two rules I looked at today. When we divide, we subtract indices. When we multiply, we add indices. I'll see you guys next time.